geometry, we're going over CO60, which is calculating arc measures using what are called central angles. Now, just like the angles of a triangle or the angles of a quadrilateral or any polygon have measures, a circle has measures as well, but it doesn't really have any angles. It has arcs. Okay, an example of the arcs would be down here below. You know, arc AB would be the distance around the outside of the circle from A to B. Okay, and arc measures are also measured in degrees. How many degrees does a circle have? I think we've covered this before. 360. Right? So the total distance around the outside of a circle in degrees is 360. For those of you that are into some esports, things like that, they say they do a 360 or a 540 or a 720. They're talking about how many times they turn around. Okay, a 360 would be a full turn. You see more of that come to the dance tomorrow night. Right?
Oh my God!
So,
I don't want to go.
A central angle. Okay.
No. How did you just draw that so good?
Had a lot of practice. I get better at circles as the day goes on. Not so good at kites. I've drawn more circles than kites. Anthony, Catherine, Claire, Rowan, Joey. Let's go.
Yo, why was that?
A central angle is an angle. Spelled and wrong. An angle with its vertex at the center of a circle. Okay? An angle with its vertex at the center of a circle. So go ahead and draw a circle in that open space. And then in the center, as best you're able to, put a dot. And then draw an angle. We'll say it's, I don't know, come out like this, coming out like that. Okay? And label the endpoints A and B. Okay? And the relationship between an arc measure and a central angle is an arc measure is equal to the central angle measure. An arc measure is equal to the central angle measure. Okay? So if you were told that this angle measure is equal to 100 degrees, then we would know that arc AB, this arc measure, is also equal to 100 degrees. And how you notate an arc is just like a segment, the endpoints of the segment, with an arc over it, just like that. Okay? So that would refer to the measure of the arc. And the relationship between an arc measure and a central angle measure is that they are congruent. And just like with acute and obtuse angles, an acute angle being less than 90, which is half of a triangle, an obtuse angle being more than 90, we have minor arcs and major arcs. A minor arc is an arc with a measure less than 180 degrees, that being half of the circle. Okay? A minor arc is an arc with a measure less than 180 degrees. A major arc would be
an arc with a
measure greater than 180 degrees. And of course, with a maximum of 360. Okay. So there's that relationship between that acute angle, obtuse angle. The other angle in a triangle is a right angle. That has a very specific measure. A semicircle is exactly 180, exactly half of a circle. It's exactly half a circle, and its measure is equal to 180 degrees. Okay? How are you doing so far?
I'm doing fine. I was done taking notes, but
Yeah. Get those definite, then we'll apply them, right? Yeah.
I just have a question.
Uh-huh.
Do Christians, as Christians, we believe God is either male or female, right?
Okay.
Wait, is that right?
I guess I don't know enough about theology to
We're in a Catholic school called.
it's not.
Do we believe God is either
I think
male or
I think it's referred to as male, but
So
it's just
Church.
great question for Mr. Boyle. He would give you,
Put it in the question box.
Put in the question box.
I just wanted to know.
Okay. 3, 2, 1. You are Wyatt. Here we go. Questions on arcs. I can intelligently, Vince, Jack, answer questions on arcs. Yes.
Noah's Ark.
So how do we know
Is
that?
that 100?
How do we know that this outside part is 100 degrees?
We know the arc measure is 100 degrees because the central angle is 100
So
degrees.
the central angle is how much?
Yes, the relationship between the central angle and the arc measure is completely congruent. It's completely the same. Yeah, it is cool. Joey. Okay.
So, Noah's Ark.
Oh yeah. That is a question about arc.
So, it's like shaped like this.
It's like a parabola.
Is it a semi?
Can you say this
exactly?
No, it wasn't exactly 180. I think the arc was exactly 180 would be more like that. I think the arc was more
It was bigger than
So, what is that?
that.
half an
Oh, it's parabolic.
That's nice.
Yeah.
Some oval.
What is parabolic? We understand.
Okay. The arc addition postulate is the same idea as the segment addition postulate or the angle addition postulate. Who remembers what those are and can apply it to arcs? Kylie?
2 parts will equal the sum of the whole.
Okay, an arc is equal to the sum of its parts, or kind of the other way around, okay? The parts of an arc will sum to equal the whole arc. Right? So when we look at the practice part down here, you'll see some arcs have 2 letters and some arcs have 3. Okay? It's actually a very important distinction because that determines whether we're talking about a minor arc or a major arc. For example, if I ask you for the measure of arc TQ, well, here's T and here's Q. We can get there 2 different ways. How do you know if you're going the short way or the long way? Okay? Well, if there are only 2 letters, it means you're going the short way. It means it's the minor arc. It's the fastest way to get from T to Q, which would be going this direction. Okay? And if you're asked to find the measure of that arc from T to Q, because we are given that central angle, what's the measure of arc TQ? 120. Equal to the measure of the central angle. Okay? You'll see the next one also has a T and a Q in it, but there's R in the middle. When there's 3 letters, that means you're referring to the major arc because it's saying, I want you to go from Q to T, but I want you to go through point R to get there. Okay?
This makes no sense.
So if there are only 2 letters for an arc, it means what's the fastest way to get there? It refers to a minor arc. Your arc measure will be less than 180 degrees. If there are 3 letters, it's telling you, go from our endpoints, go from Q to T, but pass through point R. If that's the case, it's going to be referring to a major arc. Okay?
I see.
Why is it just random letter? Why is it point R?
I don't get that.
So this isn't about the angles inside the circle.
Well, you use the angles inside the circle to get the arc measures.
I don't get that. Can you say that one more time?
Okay? Hold on.
Go through all the way to S. Why don't we put
You have to go through S as well, But if you're going through R to get to T, you have to go through S also. There's no point in putting both of them there, because if you're going from Q to T, if you go through R, then you have to go through S also. We could also call this arc QST, and it would be the same thing. It's from Q to T going the long way around. Okay? So Damien's saying it again. If an arc only has 2 letters,
Yes, that's
it's
minor.
going directly from one point to the next, the quickest way possible. Okay? The quickest way to get from point T to point Q is by going over the top.
Not, how do you know it's not going through the middle?
An arc measure stays on the outside of the circle. Okay? When you're talking about an arc, which is that arc over the letters, you're not going inside the circle at all.
Oh.
Okay? You're
Because it has that
specifically
arc
talking about the
over
arc.
it. But if it doesn't have an arc over it,
These all have arcs over them.
okay, so they all are going around it.
Yes. And the question is, are you going the short way or the long way? Because to get from Q to T, I can go the short way in green there, or I can go around the long way. The difference is 2 letters, you're going the short way. 3 letters, you have to also go through point R, which takes you the long way around.
So then how would you figure out what it is?
Okay, so how do we figure out what this would be?
Wait.
Noah?
I just have a question. Will there always be one line that goes through the middle to make it a semicircle?
No,
I have a question.
not always. There are in each of these, but not always.
I have a
What's
question.
Okay.
the semicircle for the second one?
What's that?
Which one's the line for the semicircle?
They're actually both. There are 2 semicircles there.
What?
Ellen, how do we calculate the measure of arc QRT? Okay, this is the arc addition postulate, right? We know the whole circle is 360.
Oh,
We know this part is 120. That means the remaining part has to be 240 to get to our 360 total.
wait.
Okay? Or you could calculate this angle here and then add it to our 80 and 60. That would bring you to 240 as well. Okay? Arlene.
In some cases, can vertical angles apply to circles?
Vertical angles do apply to circles. We've got vertical angles, not in this one,
In the second.
right here, okay? Because these are straight segments going through here, we know that this would have to be 70 also. Unfortunately, this one here, it kind of curves just a little bit. It's not straight through, it comes down and it downgrades slightly, okay? So vertical angles wouldn't apply there. That's why it's not congruent. One's 80 and one's 60, but here you would have vertical angles there. Okay? Yes,
Okay,
Amy.
so I get that. But so if it has 3 letters, it's always going to be the long. You always have to take the long way.
Correct.
But if it's 2 letters, then we have to take the shortest way
Correct.
possible. And then we just solve for that.
Yes,
That's like what you eat.
I hope so. Alex? Sure. Okay. Alex is asking for TQR, which I'll erase my other jottings here. TQR is this one here, and because it's 3 letters, we know we're going from point T through point Q and over to R. Okay. Now, in this case, TR, what do we know about TR? How do we know that is a diameter? What clues do we have that we can determine that's the diameter of the circle?
It goes through the center of the circle, and 120 plus 60 is 180.
Yes, David, have a seat, please. We know it's the diameter of the circle because the 2 angles that make up this arc, right? T center over to Q and R center to Q, they add up to 180. Okay? Which if these add up to 180, these 2 angles, it means this arc measure has to be 180 as well. Therefore, it's a semicircle. Lisa. Sure. Anything else? Tomorrow's a retake day, so your homework from Monday is to finish the page. There's no homework from the book. Okay? Khan Academy is due tonight. Don't forget about that. And then I'm after school today for retakes, and then in class retake day tomorrow. If you don't have any retakes to take, you'll have Khan to work on that. You do need to identify it as a minor, major, or semicircle. This would be a semicircle.
Oh
Beckman.
my.
Did you look up the retakes though?
No, I do that on
We have
the
to finish
weekends
the
only.
rest of the page.
What's that? Yes, finish CO60 for
We have
Monday.
to label it.
You need to label them minor, major, semicircle. Okay. Anything else?
Oh, no, it's actually good.
Vince? Shh.
You need to be quiet.
Thank you.
Oh, semicircle.
Alright, that is high math.
Don't forget to like and subscribe.
Thank you.